Hi, my name is Jakob Nauke. I work in cloud development for IBM Z and Linux One at IBM. And I'd like to demonstrate the confidential container setup on a trusted execution environment, which is IBM Secure Execution for Linux on IBM Z. We have a Kubernetes YAML here, which runs a service which exposes port 22 and which uses the Kata runtime class, the Kata containers runtime. Kata containers is a runtime where pods are run as tiny VMs, which allows us to utilize technologies like secure execution, VM-based trusted execution environments. And we're running a container here, which comes from here, from the Kata Docker organization. This container is encrypted, which is important because it runs an SSH daemon with public key authentication and an authorized key. And its private SSH host key should not be readable on this machine by the host. So if we tried and ran this image, it wouldn't work because it's encrypted. We use the Kata runtime class, and this is configured here in containerd using this configuration and the confidential containers cry handler. And this Kata containers configuration has some interesting settings, like the kernel. So what we do in secure execution is we run an encrypted image which contains the kernel and the init.rd and the kernel command line, and that secure image has been generated on another machine. The point is that this machine here will not be usable, will not be accessible to a hypothetical adversary cloud service provider. So this is basically a trusted instance where we build this image and where the keys for decrypting that container image also reside and are built into that secure execution image, protected image. And that image is encrypted with a machine-specific key. So we have some contents of the guest rootfs here in etc, namely keys for decrypting the image, which I'm going to show. Of course, this is just a demo key. For running this yourself, you should generate other keys, but we use these keys in a demo, so we publicize them. And furthermore, there is a configuration for the Kata agent, that is the component running inside the guest sandbox. And that configures the offline file system key broker client. So that is the component in the attestation agent that provides the key for decrypting the container image. And it's the offline file system key broker because it just reads from a file. In principle, this isn't architecture specific like other key broker clients for SEV or EAA, for instance, but it is only actually confidential when the file system isn't readable by the VM host, as with secure execution. And this also configures some endpoints, and most notably, it disables the exec process request endpoint, which we're going to see in a minute. This image that we created on a trusted machine is specified as kernel here. It also contains the init.rd, but is specified as a kernel, and there is also an init.rd specified, but it isn't actually used for anything. The confidential guest option is enabled, so this enables some QEMU specific secure execution options, and the service offload must also be enabled. This is what enables guest pull, so the image is pulled inside the guest, which we are going to see right now. So what I'm going to do is apply this Kubernetes config, and we're going to wait for the pod to be ready. And what is happening right now is the image is being pulled. Oh, there it is. The image is being pulled in the guest, which is why it takes a little time, and it is decrypted through the file that is in the guest file system that cannot be read from the host because that image is encrypted. We can now see that the endpoint, for example, for execing into this container is disabled. The exec process request is blocked, which is a fairly simple way of manipulating an existing pod. And because this is an SSH pod, the secure way to connect to it is using SSH, using a key whose public part was dumped in the container image, and we can use the private key to connect. We can also check the key fingerprint that we got when creating this container. And we're now inside the guest. And for instance, this directory would not exist without Secure Execution. And we can now set secrets like I'm going to set a shell variable to very secret data. And what I'm going to do now is I'm going to exit and run a memory dump of that guest. So this is socat to QMP because we're using QEMU. This gets the pod that we are using here and connects to an extra QMP sock and dumps guest memory to a file on the host. There it is. And what we see now with this fgrep here, which searches the pipe that this memory was just dumped to, is that no confidential data was found. That very secret data here that we just set is not found, which is excellent for confidentiality of easily deployable confidential pods.